Hello, welcome once again to my YouTube channel for the continuation of differentiation of trigonometrical functions. Now, from the previous lesson, we talked about use of the product rule. And now today we shall now also look at how to use the quotient rule for differentiating trigonometrical functions. Without wasting time, as usual, we shall begin with a general example that says differentiate the following functions with respect to x. I am basically going to begin with part A, but something that we have to remember about quotient rule is that when we have our y as sine x out of cos x, there is going to be a restriction that strictly the denominator of your function will be the one that we call v. Then the numerator will automatically be u. There is no flexibility like product rule where n of them can be u and n of them can be v. So it means by all means this has to be v and this has to be u. And so like we did yesterday in the other previous lesson, we shall now say u is sine x. We differentiate that so that we get the u dx. The u dx automatically becomes cos of x. We also get v, which is cos of x. We differentiate cos so that we have the v dx as negative sine of x. After this, we now introducing our formula for quotient rule, and that formula says the y dx is equals to v the u dx minus u the v dx, but all this divided by v squared. So that is going to be our formula, and so it means the next step is basically going to be the substitution. So if we do the substitution, it means the y dx will now be v, which is cos x. The u dx, we know it as cos x also. Minus is minus here. What is our u? Our u is sine x. Our u is sine x. But remember, now the v dx is minus sine x. Now this negative and this negative will now create a positive, and then we have sine x there. But all this divided by v squared. But our v is cos of x, so it means I will have cos of x but squared. Cos squared of x. And then the next step will be realizing that the y x now becomes cos squared of x plus sine squared of x. All this divided by cos squared of x. But when you look at the numerator, it is basically the first identity of trigonometry. But when you have cos x squared plus sine squared x, automatically the answer is 1 from the first identity of trigonometry. So it means I will have all this as 1 divided by cos squared of x. And that gives us sec squared of x. Our dy dx. Now this is very interesting. It actually reminds us that when you have sine x over cos x, then it is as good as tan x. And from first principles, we talked about the derivative of tan x and we realized it was actually sec squared x, which we still have in this case using what we call the quotient rule. Let us move in to part B. Now part B has a mixture of an algebraic expression and a trigonometrical function. So I'm going to let y to be sine of 2x divided by x squared. But as I said, the denominator strictly has to be v. Then the numerator will be u. So I will begin with the u, which is sine 2x. And of course, the u dx now becomes 2 cos of 2x. What has happened here is I first differentiated the angle to get 2, then finally multiply the derivative of the angle by the derivative of the trigonometrical function. When you differentiate sine, of course, you get cos, but make sure you first differentiate the angle, and then you come up to 2 cos of 2x. Then from this point, we can go on and look for dv dx, because we know v is equals to x squared. It means dv dx is automatically going to be 2x. dv dx is automatically going to be 2x. Then we bring in the formula for quotient rule, saying dy dx is equals to v du dx minus u dv dx divided by v squared. Divided by v squared. From this level, we can do the substitution so that we have dy dx is equals to our v is x squared and our du dx is 2 cos of 2x minus u, but our u is sine 2x, and our dv dx is 2x. So I'll have 2x there. All this divided by v squared, but remember v was x squared, so I'll have x squared but squared, which comes to x power 4. So this will be x power 4. Now when we try to simplify the numerator, we shall have 2x squared cos of 2x minus 2x sine of 2x. All this divided by x power 4. From this point, we can now quickly conclude that actually dy dx is going to be, we can first look at the common factor. I have 2x as a common factor, as you can see. 2x is a common factor. So when I pull out the 2x, I will have to remain with x here, but cos of 2x minus, this now remain as sine 2x. All this divided by x power 4, and from the rules of indices, we can use it to reduce this with this. So the x cancels here, then reduces this by 1, so that I have dy dx as 2 into brackets x cos of 2x minus sine of 2x. All this now divided by, I can put it x power 3. Why? Because we reduce x power 4 with this x here. And that gives us our answer for that expression. Let us now move very fast to part C. So part C, they gave us cos power 4x out of x squared. We are not going to waste much time here because we already have the ideas. I'll quickly call this v, call this u. So it means our u is going to be cos of x. I can first call it power 4 to simplify the definition later. Now we are going to use the shortcut of chain rule again. We shall drop the power, differentiate the function inside the bracket, rewrite back the same bracket with its content, but with its power reduced by 1. So it means du dx comes to 4. When I differentiate cos x, I will get minus sine x. Then I write back the same bracket, cos of x, but of course I reduce the power by 1. So the answer comes to minus 4 sine x, then cos cubed of x. Next, we now also have v as x squared, so we shall get dv dx. Now dv dx comes to 2x. Now if dv dx is that, bring in the formula. dy dx is going to be v du dx minus u dv dx divided by v squared. So we do now the substitution. So that now dy dx becomes v, which we know as x squared, du dx, which we know as minus 4 sine x cubed of x minus, we have this minus here, u, but u is cos power 4x, cos power 4x, and the big x is 2x, so I'll have a 2x there. All this divided by v squared, whereby now we shall have x power 4, because our day was x squared, but squared again gives us x power 4. Then from this level we can try to do the simplification, especially the numerator. I can see that actually we shall obtain minus 4x squared sine x cos cubed of x minus 2x cos power 4x, all this divided by x power 4. Now from this, I can now try to think harder on how to simplify or write the last very step. So I will have the y x. When I look at the numerator, yes, I see minus 4 and a minus 2. So a minus 2 is a common factor. I see x squared and x. X will be a common factor. I see cos cubed and cos power 4. So I will bring out cos cubed of x as a common factor into brackets. Now from this we took a minus 2, so we made it 2. X squared we took out x, so we made it x. Sine has remained there, so we have sine x minus 2 went out with a minus. Actually it's not going to be a plus because we took out a minus 2. So x also went out. Cos power 3 went out, so we made cos of x. All this divided by x power 4. Now this x and this x can also simplify to a point where now we have minus 2 cos cubed x into brackets 2x sine x plus cos of x. All this divided by x cubed. All that divided by x cubed, and that will be our final answer. So that was part C of the question. We can now do part B. Then for part E, as usual, we shall also have to try it. So we shall move through it very fast again because we have the ideas. The denominator automatically has to be v, the numerator has to be u. So now this time round we have the u as cos cubed of 5x. But we need to be very careful when we are differentiating, because remember you have to differentiate the angle, but again you also have a power. In fact, it would be simpler for a student, especially for a student, to have these all as power 3, which is very much okay. Then you say the u, the x, now becomes, you drop the power, differentiate the function within the bracket. So when I differentiate cos 5x, I'll get minus 5 sine 5x. Why? Because you first define the angle, then you differentiate the three functions. I write back the same bracket with its content, cos of 5x, but I reduce the power by 1. So that becomes 2. At the end of the day, we shall have minus 15 sine 5x cos squared of 5x as our du dx. Then our v is supposed to be 6x. Automatically the v dx becomes 6. Then we bring in the formula. dy dx is equals to v du dx minus u dv dx. But remember, out of v squared. Out of v squared. Then from that point we do the substitution, so that our dy dx becomes v, which is 6x. We are multiplying by du dx, but du dx is the whole of this. So I will have minus 15 sine of 5x, sine of 5x, then cos squared of 5x minus space. I'll create some little space there. I'll create some little space there, minus. We now have u, which u is cos power 5. Cos power 5. Sorry, it is cos power 3, I beg your pardon, of 5x. But multiplied by the mean x, which is 6. All this divided by v squared. Divided by v squared. V squared is supposed to be 6x plus squared, which comes to 36x squared. So this will be 36x squared. So without even wasting time, even if I don't first open the brackets to make life so easy, I can realize that there is a 6 common factor. 6 common factor. When it comes out, it will reduce 36 to 6. So it means I can now open my bracket by saying minus 15x sine 5x, then cos square of 5x, minus the 6 I am now looking at it to have cancelled. So this is cos cube of 5x. All this divided by, now we have a 6 here because we reduced 36 with 6. So that will be 6x squared. And as you can see this, unless otherwise, but our new x now becomes minus 50x sine 5x. I beg your pardon, I think you can pull out cos squared. You can simplify one, pull out cos squared. Cos squared of 5x, yeah, is a common factor into brackets, minus 15x sine 5x minus, we pull out cos squared, so we remain here with cos of 5x. All this divided by 6x squared, and that becomes our result. Now, for part E, it is also going to be a trial, and then from there we build up the knowledge to proceed to the next video. Thank you very much for being good viewers.